Hi everybody, so we are on to our third exponent rules video for this chapter, and today we're going to look at what happens when you have 0 or a negative number as an exponent. So one of the ways we can kind of investigate how this works is using our calculator with some numbers. So let's try, for example, typing in some of these problems on our calculator and seeing if we can figure out what's going on here when we have 0 as an exponent. Let's start by typing in 5 to the 0. If we type in 5 to the 0, the answer is 1. Let's try 35 to the 0. If we type in 35 to the 0, the answer is 1. Well, that's odd. I wonder what happens when we have 3 times 6 to the 0. The answer is 3. And let's see if we can use that to figure out exactly what's happening when we have x to the 0 so that we could apply it to this question, because we know we can't type x's in on our calculator. Well, it seems to me that when I have something to the 0 power, the answer is 1. So then why would this possibly be 3? Well, if you think about it, the 0 power only applies to the 6. So if that part of this problem becomes the value of 1, then what I really have here is 3 times 1, which is how I get 3. So now I know that anytime I have a power of 0, the answer to that problem is 1. So if I look at this problem, if I'm evaluating 3 times x to the 0 power, the answer is going to be 1. Because having a 0 power turns whatever number is inside there and it makes it into a 0. So what is the pattern? The pattern is that raising a base to the 0 power changes or equals 1. Sometimes mathematically what we write is x to the 0 equals 1. No matter what the base is, when you raise it to the 0 power, you get 1. Now let's see if we can investigate what happens when you have a negative number as a power. So just like before, we'll start with some numbers. So 2 to the negative 1 would give me 0.5. Now I'm going to make that into a fraction so I can see this pattern better, which is really 1/2. 2 to the negative 2 would give me 0.25, and if I make that into a fraction so I can see the pattern better, I get 1/4. Now 1 divided by 2, if I make this into a fraction, 1 divided by 2 to the negative 2 power becomes a 4. And let's see if we can use those three problems to figure out a pattern that we could use to apply to this problem. So it looks like 2 to the negative 1. Well, 2 to the positive 1 is just 2, and it looks like the 2 just moved to the bottom. So I just raised it to a positive 1 and then moved it to the bottom. Here, if I do 2 to the positive 2, I get 4, and then I just put it on the bottom. But now this one started off on the bottom. I'm still going to do 2 to the positive 2 and I get 4, but then it moves to the top and it becomes a regular 4 instead of a 1/4. So it looks like that negative by the exponent is another way of saying move where this is located. So x to the negative 3 would be the same as x to the positive 3. It would just be on the bottom of a fraction. The rule here, and what we usually say, is that if your exponent is negative, then you drop it to the bottom of a fraction. If it is already in the bottom, then you move it to the top of the fraction. So sometimes, because I like songs and I like for things to rhyme, what I say is that if your exponent's negative, you drop it like it's hot. If it's already on the bottom, then you bring it to the top. Now you'll notice that when we dropped it, it became a positive power. So when I dropped this x to the negative 3 to the bottom, it became a positive 3. By moving it, you make it positive. So here's what we sometimes say. X to a negative number is really just 1 over x to the positive number. So just move that to the bottom and change the exponent to a positive. We also sometimes say that if you're already on the bottom, 1 over x to a negative number, then you just move it to the top and you make it a positive number. By moving it, you make your exponent positive. Now that's going to be a neat trick for us because we usually want to write all of our final answers with positive exponents only. So if there is a negative exponent, we use this rule to kind of shift things around to make it look nicer. Let's look at some examples. So let's start with problem 1. Using the rules, I know that anything to the 0 power is 1. So my answer here would be 1. For problem number 1. Now some students would say, well, don't you have to distribute that power? And that is definitely an option. So one option is just to say this is equal to 1. Another option is to say, well, if I distribute the power, I would have x to the 0, y to the 0, times z to the 0. Now each of these individually would become 1. Which means the final answer would be 1. And you can do either one of these options. If you're somebody who's like, listen, I always like to distribute the power before I try to simplify, then you could do it that way and still get the right answer. For problem number 2, it's important to recognize that only the 2x has the 0 power. So the 4 is going to stay, and the 2x is going to turn into a 1, which means my final answer is just 4. So having a 0 power doesn't make the answer to the question 1, it makes that term or factor turn into a 1. Now let's look at some negative powers. Again, we should think about the negative not as a negative number, but as a direction change. So right now, if this has a negative exponent, what I'm going to do is move just that factor, so not the 3, just the x, to the bottom of a fraction. So the 3 is going to stay where it is. And then I'm going to move the x to the bottom, and I'm going to change my exponent to a positive 2, because once you move it, you get a positive answer. You made it happy, it becomes positive. In problem number 4, the term or the factor that has a negative exponent is already on the bottom, so I'm going to swing it back up to the top. The 7x squared will stay there, and the y to the 3rd will join that on the top. Now there's nothing else that I can simplify here because x and y are different bases, so now I'm done. Again, thank you guys so much for watching. I really appreciate you paying attention and taking really great notes, and we will see you in class tomorrow for some extra practice. Have a great night.